try to teach you a couple things. So in chapter 15, we've covered 15.1 and 15.2 kind of. I want to pick up here in 15.2 before I move on into anything new. You know, I want to just remind you of this thing here. So, you know, what we used to do way back in Cal 1 was we used to integrate a function, dx, and sometimes we would integrate it from a to b. And the concept was we were integrating over an interval. We were integrating with respect to x, and we were integrating over an interval from a to b. We were integrating kind of along this x-axis, some function, but we were integrating over an interval. A function over an interval on the x-axis. That's what we were doing. And we spent our whole life doing that for a while. Just in chapter 14, in this class, in Cal 3, we learned how to do a double integral over a region R. So then we were integrating a 3D function over a region R. So then we were integrating, you know, over some region R. So that was what that was. And then as we've eased into 15.2 here, what we've learned about is this new thing called a line integral. So this was my lecture last class, and so now you're integrating over a curve. Now there was two types of these line integrals, but again the thing is we're integrating along some curve, some path or some curve C. And by the way, the curve has orientation, so we integrate in one direction or perhaps the other. But there was two types of these line integrals. There was this one, where you integrate some 3D function over this curve in the xy plane, but you integrate with respect to s, which is the arc length of that curve. So I did one of those. This is in 15.2. And then the other important one in 15.2 is this, integrating this. Again, it's over a curve, but we're integrating f dot dr. So there's two types of line integrals in section 15.2, and we should get good at both of them. But the truth is, the rest of the chapter is this one, the second one. So on your test and on your take-home quiz, and you know, anyway, you should practice a couple of those. But the 80% of this class, or 70%, is going to be this one. It's not going to be this one. In the previous lecture, I talked about some meanings for this one that I'm not too excited about. This one does have meaning. It is it's a different problem. It's a different problem, as you can tell. This is a scalar function integrated over the length of some curve. This is the work done by a force field. This is on a curve that goes through a force field. So this is the work done by the force field, which is the vector field F, which the work done by the vector field F on a particle, I wrote this the other day, on a particle as it travels the path C. On a particle as it travels the path C. So that is meaning, and that's the physics term work, which by the way can be called energy if you want to.
Are we coming?
Yeah. What do you want?
We just have one quick question. But
You have a quick math question?
Is this the class yet?
Well, this is my class. This is my Calculus 3 class.
That's it?
Yep, someday this is where you want to be.